Yeah. So, hello guys. Good evening, everyone. Welcome to DurgaSoft online training sessions. Welcome to DurgaSoft online training sessions. Myself, Prakash Babu, having 15 years of experience as a trainer. Okay, having 15 plus years of experience as a trainer, sir. Okay, so here we are going to launch a new batch. So DSA with Java. DSA with Java. Okay, so the prerequisite for this batch, prerequisite is nothing but so compulsory. Okay, compulsory. You should have Java knowledge. Okay, what is a prerequisite for this? Core Java knowledge you must have. Sir, without this core Java knowledge, it is very difficult to understand this DSA because, sir, it is not theory related subject, sir. Okay, completely we are going to handle the programs. That's why whenever we are implementing the program, compulsory you are going to get n number of doubts. So like we have to focus only on the development side. So any syntactical errors, those things we should not focus. That's why compulsory you should have knowledge in core Java, then only you can able to understand very clearly. This is point number one. So what is the duration of this course? Actually it is a weekend batch, sir. So we are going to take 5 weekends. From next week onwards you need to count. Okay, from next week onwards you need to count. Sir, what is the fees for this batch? I think already you have seen rupees 3000. Rupees 3000. Sir, if anyone willing to join, immediately you can join, because for the next 2 months or 3 months there won't be any DSA batch. Okay, so next thing, what is the timings? This is very, very important, sir. What is the timings of this session? Sir, the timings as of now we displayed in the demo like 9 p.m. But actually the session starts from 9 p.m., sir. So 9 p.m. to 7 p.m. to 8 p.m., 8 p.m. to 9 p.m., 9 p.m. to 10 p.m. Total 3 hours session will be there. And my sincere request for everyone, so please available. Okay, please available on weekends. Okay, weekends, because we are not going to take only in between the timings. So please available from 5 p.m. onwards. Okay, 5 p.m. onwards on weekends. Why? Because sometimes I'm going to take split sessions like 5 to 7 one session, then 1 hour or 1.5 hour break after that. Or sometimes if any easy topic is there, I will start at 5 o'clock, but rarely this will happen. Okay. So actually the timings of this session is not from 9 o'clock, from 7 to 10. 7 to 10, sir. Please stick on to these timings. 1 hour earlier, sometimes I may start. That intimation I will give. Okay. This is nothing but the duration. I mean, this is nothing but the details of our course, sir. Sir, what you people are going to get? Running notes I am going to share. In addition to that, videos also you are going to get. Running notes is lifetime validity, sir. But videos you will be having access only for the 6 months from the date of your registration. This is nothing but the details of the course. If you are having any queries on these details, please let me know. Then I will explain what syllabus we are going to cover. Any questions? Sir, any questions?
No, sir.
Right. Coming to the syllabus. Sir, what topics we are going to cover? What topics we are going to cover? Sir, at the very beginning, I am going to explain like introduction. Introduction to data structures. Okay, introduction to data structures. And I'm going to explain and I'm going to explain even introduction for algorithms also, like what is mean by algorithms, how to develop algorithms, some sample algorithms also. After this, we are trying to learn how to calculate time and space complexities. Sir, if any algorithm or if any program is there on your hand, how you are going to calculate time and space complexities? After this, there are some basic data structures like arrays and then string. So these are basic data structures what we have. We are going to see some theory part as well as more we will see on hands-on, sir. On arrays, minimum 20 to 30 programs we are going to see. On strings also around 50 programs. I am not going to explain all the programs. The programs which is difficult for you, I will explain, and easy programs you can able to solve. Okay. So for the first time, for this batch, I am using some Java 8 features also for solving the programs. For solving the programs, I am introducing not core concept. I will use Java 8 features also. Okay. This is nothing but what we have. Sir, after this, recursion, recursive algorithms we are going to see. After this recursive algorithms, we are going to discuss about backtracking. What is mean by backtracking? How you can able to apply this backtracking? After that, so divide and conquer algorithms are there. We are going to talk about these divide and conquer algorithms also. Okay, so after this, we are going to talk about dynamic programming, which is very, very important. So I'm going to demonstrate some three applications on this dynamic programming. Then greedy methods are there. So like in this also around three applications we are going to see. Then sorting algorithms. So what are the various sorting algorithms are there? Like a quick sort, merge sort, okay, insertion sort, bubble sort, selection sort, like that, and searching algorithms like binary search, linear search, like this. So after this, how we are working with the hashing. Hashing, some people may use the word called hash table. Then linked list. So we are going to see single linked list, double linked list, okay, circular single linked list, circular double linked list. One complete weekend we are going to spend on this. Okay. Sir, next weekend, this topic only I am going to discuss. Sir, after that, stack data structure. Okay. Next, queue data structure, how to implement this stack and queue. Then, so tree data structure. Okay, tree data structure. So in this, we are going to see binary tree means what? Next and after that, binary search tree means what? Then AVL tree. AVL tree means what? Then heap tree means what? Sir, heap tree means what? Something it is like a priority queue. Priority queue. After that, we are going to see graph data structure also. This is nothing but the syllabus topics which we are going to cover on these 5 weekends. Okay. Sir, any questions? Feel free to ask your queries on the syllabus.
What about two pointer and sliding windows?
Sir?
Satyam here. What about two pointer and sliding windows?
No, sir. Those things won't be covered here.
Okay.
Any other questions?
In graph, BFS and DFS and flood fields all will be there, right?
Yeah, we are going to see BFS and DFS, and we will see some algorithms also like how to find out shortest path, and is there any path is there between the two vertices, and we are going to see some 5 to 6 applications on this graph. Spanning tree, minimum cost spanning tree, those things. Okay. Any queries? Clear? Shall I start?
Yes, sir.
Yeah. So because it is the demo session, okay, so it is the demo session. So I'm not going to start from the beginning because introduction and all, so theory part, right? That's why, sir, this weekend I'm going to take this recursive algorithms. Okay. So this is nothing but you can consider as week zero, week zero. Sir, recursive algorithms I'm going to take, and in the next week I'm going to start linked list. So next weekend we will be having linked list, sir. The timings of next week session is nothing but what? 7 p.m. onwards. Okay. So next weekend the session is from 7 p.m. onwards. Okay. So before joining to the session, so these 2 days, today and tomorrow, we are going to see recursive algorithms. Okay. Now, let us start recursive algorithms. What is mean by recursion? How you can able to work with this recursion? That total theory related points I will demonstrate night. Okay. Sir, now anyone can you please tell me the definition of recursion in your point of view? So I think already you have some idea, right? Sir, anyone tell me?
Calling a function again and again from within function.
Good, very good, very good. So calling a function, or I can say method, because in Java we have to call it as a method. Calling a method by itself is called as a recursion, sir. Okay. Now listen carefully. I am saving this program with a test.java. So I want to compile the program. See, in our previous, of course, our batch only, we have seen backtracking. In the backtracking, we solved Sudoku problem. Just a few minutes back, we completed this Sudoku program. Okay. Yeah. So now we need to see how this recursion is going to work. But to understand recursion, whatever knowledge you have on recursion, so is not sufficient. We need to go in detail. That's why in today's session, how recursion is going to work in the backside, I'm going to demonstrate. Sir, how to compile the Java program from the command prompt? We know we have to use Java C command to compile the Java program. Sir, how to execute Java space test? You can see what is output we are getting. Hello world. Like this we have. Now, sir, for moving into the recursion, I want to take one simple example. What is this example is, see, I'm going to call one method, sir. I will print some message saying main method execution started. Like this, I'm giving some message. Main method execution ended. Like this, I'm giving. Sir, meanwhile, I'm going to call some method called M1. Sir, what is M1 here? M1 is a special method which is already there in the test class. What this M1 method is going to do? It will print the same messages like M1 method execution. Okay, M1 method execution started. M1 method execution ended like this. Meanwhile, I don't have any redirection. Sir, we know the output. What output we will get? Sir, if you see first main method execution started. After this line, the control is moving to the method one. In that there are two statements. Those two statements will be executed. After that, what will happen? Is there any other thing after method call? Yes, those lines are going to be executed. We are clear with the output of this program, but internally what will happen? You need to analyze. Sir, what is happening internally? There is one stack. There is one stack will be created. So what is that stack? Sir, assume that this is nothing but a stack. So we know the principle of stack. Can anyone tell me what is a stack principle? What
First
is the
in,
principle?
last out.
First in, last out, but better to use last in, first out. What is the meaning of that? So whatever be the last inserted item, that will be the first accessing. Now, JVM responsibility is to start the program execution. Sir, JVM is going to call which method? Main. Immediately that entry is there, right? Sir, I am calling main method. That entry will be stored inside stack. Then immediately it will start executing. So what is the output? This is nothing but the first line which is going to be printed on the output. Then what is happening? We are calling some other method, sir. These method calls will be stored inside stack. So now main is calling which method? The method M1. Now what will happen? Method M1 execution is going to be started. Sir, is there any other method calls? No. So this is the second line and this is the third line on the output. Then what will happen? It will return to the original place. Before returning, what will happen? This method execution completed, right? Hence, what is going to be done is, sir, in the stack, it will delete this entry and it will come back. Sir, who called M1? Main method, right? In the main method, is there any pending instruction? Yes. Let us execute this. That's why it is a fourth line. Then delete this entry and report to JVM saying all method calls completed. Can you please go ahead? That's all. Like this, all the method calls are always available inside stack. Why? Because which is the latest method called to maintain that track, they are going to use the stack internally. So this point is very, very important, sir. Why? Because based on this only, the total story of recursion, almost I can say, so everything is going to be done. Sir, any doubts up to this? Any questions up to this?
No, sir.
Clear?
No, yes, sir.
No. Sir, same thing. So what I'm going to do is, I will add few more methods. Like this, I'm going to take another method like M2. Sir, meanwhile, in the M1, what I'm going to do is, I'm calling another method called M2. So that what will happen? The method redirection is going to be happen. Please see the diagram. JVM is calling which method? Main method. So main method is calling which method? M1. So M1 is calling which method? M2. So like this, the entries will be there. After completion of M2, it will delete corresponding entry from the stack and it will come back. It will delete the entry from this and it will come back. Like that, it is going to report. I think you know the flow of execution. What is the first line? Main method execution started. Then M1 method execution started. Please make sure that M1 method execution ended won't be printed because it is redirecting to some other method. So it will print that. Then M2 method execution ended. At last M1 method execution ended and at last main method execution ended. If you want, you can see. Sir, main method execution started. M1 started. M2 started. M2 ended. Then M1 ended. Then main is also ended. Sir, any questions up to this? Is the second example clear?
Yes.
Now, I don't want to go in detail, but with one last example, I will wind up. So what is the last example is, sir, same, I'm creating one more method M3. Okay, M3 execution, M3 execution, M2 is calling M3. Now you know the flow of control. See what will happen? Sir, first main method started, M1 started, M2 started, M3 started. Which is the recent call? M3. So it will end first. What is the next recent call? M2. It will end first. Sir, last inserted method. M2 is the last. That's why M2. So M3 is the last. Like that, it is going to work. This is the way. What is the method calls inside stack means you need to understand in the background what is happening. Sir, are you clear with this? If you are clear, I want to highlight some 7 points regarding this. Clear? Any questions?
Yes, sir. Yes.
Right. So what is the note points I want to highlight? Listen carefully. You have to give justification. If you are having any doubt here, please let me know. 1 second, sir. Please wait. Yeah. So what is the note points here is, listen carefully. Sir, first note, a method can call another method. Am I right? Please confirm. Yes or no? A method can call another method. Correct?
Yes.
Yes, sir.
Second one, a method can call same method again. Is it possible or not possible?
Possible.
Yes, possible. A method can call another method. Same likewise, a method can call same method. Sir, please respond. Why? Because this is the data structures class. If you interact more, you can ask more questions and you can get clarity. That's why please don't be silent. Okay. So now third point. Sir, a method which is called by itself is called as, okay, recursive method. Sorry, a method which is called by itself is called as what? Recursive method. And this process is called as recursion. I think you got the definition for recursion. Recursion means what? A method can call same method. That process is there, right? That process is called as what? Recursion. Clear, friends?
Yes, sir.
Yes.
Now, sir, I want to take one example, sir. I want to take one example. What is this example? Sir, I am removing all these method calls. I will take only one method. Let it be m. So what I will do is, sir, main method is calling m. Now control will come here. What m is doing? Sir, it is printing system.out.println hello. After this, sir, again I am calling the same method. Again, I am calling the same method. Now see what will happen. Sir, a stack is going to be created like this. What is the first entry in the stack, sir? Main. Am I right? What is the second entry?
M.
M.
Second. Yeah. So first entry is nothing but what? Main. Main is calling which method? M. Sir, now tell me, M is calling which method, sir? M is calling which method?
M.
M. Very good.
Again,
It is calling again M. So it is calling again M. Sir, tell me, is it never ending process? Correct?
Yes.
Sir, is it a stack or not? This stack is going to overflow. That means it will be filled. Why? Because my Java is going to allocate only some memory for this storing stack. Okay, once if this memory is out, then what will happen? n number of things will happen, sir. That's why they are going to restrict up to certain time. Whenever overflow is happening, we are going to terminate. Now see, let us see practically what is happening. Java C test.java. If you are running, sir, keep on working, keep on working. But at certain point, it is going to stop. Okay. So my stack, my memory, my stack is nothing but very full. Okay. Now you can see somewhere in the middle, I'm scrolling. I'm scrolling. So somewhere here you can see exception in thread main java.lang. What is that runtime exception? Stack overflow error. So when you are running this recursion, so what problem you can able to get? Stack overflow error. What is this stack overflow error? Because there is some restrictions. So recursion always leads to which error, sir? Stack overflow error. Stack overflow error. Sir, how to stop this? To stop this, okay, to stop this, so we have to, okay, so we have to use, so one special condition. What is that special condition? Base condition. I will write base condition, how to prepare. Sir, if you have, okay, if you have a common pattern, okay, if you have a common pattern, then recursion is best choice, sir. Sir, some people are going to ask, sir, when we should go for recursion? If there is a pattern, then you have to use the recursion. Best example, sir, someone asked to add five numbers. Okay, someone asked to add five numbers like A plus, so B plus, C plus, D plus E, like this. Sir, is there any common pattern? Yes. If you take two numbers, it is doing addition. Whatever result you are getting, take that result and perform same pattern, right? In this case, taking two numbers and adding. In this case, also taking two numbers and adding. Sir, whatever result you are getting, taking those two numbers and adding. Whatever result you are getting, taking those two numbers and adding. So whatever result you will get, that is the final result, right? Like if you have any common pattern, identifying this pattern is the very difficult job, sir. Once if you identify the pattern, there ends the matter. We can develop any big program into small code. So I hope the small input related to the recursion I provided. Sir, if you are having any questions, please let me know. Any questions? Yes, please confirm. Everyone feeling comfortable?
No questions, sir.
No questions.
Right. So next point, there are multiple cases are there in this recursion, sir. Multiple cases are there. What are those cases in the sense? Sir, case one, based on number of method calls, based on number of method calls. So we have two types of recursions are there, sir. Okay, based on number of method calls. What is the first one is finite. Okay, finite recursion, or let me write first infinite recursion. So second one is what? Finite recursion. Infinite recursion means what? Sir, which never stops. The example, whatever I covered previously, this one is nothing but what? Example for infinite recursion. Sir, can you please write finite recursion? Yes. I told if you want to write finite recursion, which condition we have to take, sir? Anyone tell me? I forgot. Anyone tell me?
Common conditions we need to take.
Yes, we have to write base condition. Okay, base condition we have to write. Okay. Yeah. So now see, what is the finite loop I'm going to take? Sir, how many times you need hello? That you have to fix. For example, I need only 4 times, sir. Then pass that 4 as a parameter. And what type of value we are sending? Integer, right? At the time of method declaration, take that. And check whether that is equal to 0. If it is equal to 0, put return. Otherwise, print hello. And after this, what I am doing? N minus 1. Now, For your easiness, I am going to take one special diagram, sir. See what will happen. First m is going to be called by taking a parameter called 4. Then control will come here. It will check, is n is equal to 0? No, sir. Then how many lines are there? 2 lines. What is the first line? It will print hello message on the screen. What is the second line? It will call the same method by passing n minus 1. What is the n value here? 4, right? 4 minus 1 means 3. Then again from here it will go. Sir, is n value got updated? Is it equal to 0? No, sir. Then what will happen? It will print the message called hello and it is calling m by taking n minus 1. What is the current n value? Every time these entries will change because in the stack, first main method is going to call m of 4. This 4 will be maintained in this stack. Then m of 3. The 3 will be maintained here. Okay. Now m of 2. So for 2 again what will happen? It will print hello and it is going to call m of 1. For m of 1 again it will print hello and it will call for m of 0. Sir, whenever m of 0 is coming, we are going to stop the process. Now how many times we got this hello? 1, so 2, 3 and then 4 times. Our requirement got fulfilled, right? Yes. Let us cross check. Execute this program. Compilation fine and execution. How many times I got a hello message? 4 times. That depends on your requirement. You have to change the proper base condition. So base condition is nothing but what? So when you need to terminate the program, for that purpose we have to write which condition? Base condition. Are you clear, friends? Any questions?
No, sir.
No, sir.
So if you want, let me add that base condition definition. So what is the base condition definition here? I'm going to write in terms of statement. So what is this base condition? Sir, base condition is nothing but to terminate. Okay, to terminate or to stop recursive process. So we have to supply, okay, we have to supply an explicit condition while defining the method calls. Okay, method calls. So this condition is called as what? Called as base condition. Sir, very, very important. The heart of entire recursion is nothing but what? Base condition only. If base condition is not there, recursion not that much depth. Sir, clear up to this? Any questions?
No, sir.
Right. So
Sir,
second, yes,
So
please.
how we apply base condition?
That depends on your requirement. See, one simple scenario I will explain, madam. For example, I have 2 characters are there. Okay. I want to take the combinations. You will start from here and you will go to the next character. When we have to stop? When the no character is present, we can stop. What is the base condition? If the length of the string is equal to the index value what you are maintaining, you have to stop. Correct? Index value is initially 0. Next 1. Whenever it came to 2, we have to stop. Are you getting, madam?
Yes, sir.
So like that, depending on the problem statement, the base conditions are going to be changed. Any questions? Sir, everyone clear with the first case, right? Finite recursion means what? Infinite recursion means what? Clear?
Yes, sir.
Yeah. So case 2. What is the second case? Sir, based on number of methods. Okay. So we have two types of recursions are there based on number of methods. Sir, first one is direct recursion. Second one, indirect recursion. Sir, I am not taking any example program. Maybe I am explaining only theoretical part, sir. Sir, what is mean by direct recursion? When you have a method like this, inside this, I am taking a group of statements. Okay, inside this, I am taking a group of statements. Sir, here I am calling M. What is happening? After executing these 3 lines, again I am calling the same method. This is called as what? Direct recursion. Sir, indirect recursion means what? I have method M1 is there. So inside this, we have some lines of code is there. It is calling M2. And that M2 is having one line to be executed. After that, it is calling M1. Sir, anyway, it is also never ending process. M1 is calling M2. M2 is calling M1. Again, M1 is calling M2. Something like a deadlock race condition. So it is keep on working. So both are nothing but infinite only. But how many methods we have? If you have only one method, it is called as a direct recursion. If you have multiple methods, in between navigation is happening, it is indirect recursion. Are you clear with this? Clear,
Yes,
guys?
sir. Yes, sir.
Right. Last case, which is very, very important. Okay. It will give leads to the next program, case 3. What is the case 3 here is, sir, based on place of recursion, based on the place of recursive call. So we have two types. We have two types of recursions are there. So based on the place where you are calling. The first one is tail recursion. The second one is non-tail recursion. Okay, based on the place of recursive call. Don't worry. Once if you see one example, then only you can understand. So I am taking one program. Here I am passing m of 4, right? Public static void m, integer m. So if n is equal to 0, I am returning. Otherwise, after printing hello, I am taking n also, sir. Okay, after printing hello, I am printing n also. Now, sir, I want to see what is happening. Now observe carefully. Sir, what is the first method called? M of 4. So what this m of 4 is going to do? It will print hello followed by the number. What is the n value, sir, in this case?
4.
4.
4. Can I say the output what we are going to get is at very first line, hello 4. Then what will happen? It is calling m of 3. Up to this, any questions?
No, sir.
No, sir.
Then m of 3, what it is doing? It will print hello followed by 3. So the next line output is nothing but what? Hello 3. Now what is happening? M of 3 minus 1, which is nothing but 2. Then it will print hello 2. So it will print hello 2. After that, what will happen? It is calling m of 1. Then what is happening? It is printing, sir, hello 1. Then it is calling m of 0. So it is printing hello 1. Whenever m of 0 came, simply we are returning. Nothing is going to be printed. So what is the output? Hello 4, hello 3, hello 2, hello 1. Sir, clear up to this?
Yes,
Let me
sir.
check. Let me check. Is it happening? Clear, everyone? Any questions?
No, sir.
No, sir.
Please confirm, guys. Clear?
Yes, sir, clear.
Right.
Yeah.
Now, very, very important. I'm going to talk about non-tail recursion. Sorry, here, this is called as tail recursion, sir. What is the definition that you are going to give for tail recursion? Observe carefully a small change. Inside recursive method. So after recursive call, if we are not taking any statements or any instructions, then such a type of recursion is called as tail recursion. So what is the meaning here? After recursive call. Sir, which is recursive call? This one only. Sir, after this recursive call, have you taken any statements? No, sir. Then it will become tail recursion. That's all, sir. Sir, what is non-tail? Opposite for this. Anyway, I will take example, then only you will get clarity. Up to this, any questions, friends? Please confirm.
No, sir. Clear.
What is mean by non-tail? Sir, can I say same definition inside recursive method after recursive call? If we are taking any instructions, then it is called as what? Non-tail recursion. Non-tail recursion. I will take one example. You will get clarity. Sir, I am replacing this line here, sir. Now, what is this one? Non-tail recursion. Non-tail recursion. Sir, how? The flow of control is completely going to be changed. This is the output for our previous program. I will keep as it is. So now again I am going to draw a fresh diagram for this by changing the color. Observe, what is the first method called, sir? M of 4. Am I right? Now what is happening? Sir, tell me, after this, these are the two lines. Which one will execute first? Sixth line or seventh line?
Like,
Sixth line. Sir, sixth line is doing m of 4 minus 1. Sir, it will navigate to the next method call. Am I right?
yes, sir.
This line won't be printed. Correct?
Hmm.
Correct.
Then what will happen? M of 3, again
M
it
of
will
2.
navigate to M of 2. M of 2, it will navigate to M of 1. So
M of
M
1.
of 1 is navigating to M of 0. Whenever M of 0 is coming, it will return. That's all. Sir, is the program is completed? No, sir. Who will execute this line? Sir, point is clear. Now, again it will come back. Sir, in the stack, what is the first entry? M of 4. What is the second entry? M of 3. What is the next entry? Sir, M of 2. What is the next entry? M of 1. So what is the next entry? M of 0. It is not executed. So it will delete and it will come back. Tell me what is the most recent call? M of
1.
1. So now it will print. So hello followed by 1. So the output is nothing but what? So hello followed by 1. Then completed, come back. So M of 2. So here there is one more statement like hello 2. So what will happen? Sorry, here hello 2 because here hello 1. Why? Because this 1 is coming. Here 2 is coming. So here 3 is coming. So now what will happen? So hello 2 will be printed. Then hello 3 will be printed. Then what will happen? So hello 4 is going to be printed like that. So this is the output. Sir, is there any change in the output for the previous program and this program? Change is there or not?
Yes, sir.
Sir, are you seeing any changes?
Number is in ascending while descending order.
Yeah. This technique is called as what? Non-tail recursion.
Non-tail.
So after recursive call, if you are getting any statement, then it is called as what? Non-tail. Any queries? Is the concept is clear? What is mean by tail and what is mean by non-tail?
Yes, sir.
Sir,
Hmm.
for hello, sir.
Yes,
This
tell me.
is sir. For non-tail, how this value is? I mean, from where this value is taking, sir? Like
From
for,
the stack, from the stack.
okay.
In the stack, they will maintain all the values. See here, how many variables are there? Only one variable n, correct?
Yes.
So in every method call, what is that n value? Who is responsible? That stack will maintain that data. That's why when you are navigating from the methods, that is the reason why I explained the stack at very beginning. Because all the method calls will be stored in that stack only. That stack is responsible to hold all the n values at every frame. Which frame you are executing, it will give that n value. Okay.
Yeah. Got it.
Clear, everyone?
Yes, sir.
Now, sir, listen carefully. In what kind of scenarios we can use tail and what kind of scenarios we can use non-tail? Sir, very simple. Whenever you want to move in forward direction, then we have to use one recursion. Whenever you want to travel in the backward direction, you have to use another step. That's all. Very simple, sir. Nothing is required. So in different scenarios, you got one situation, like sometimes they may ask reverse the given number, reverse the given string. Okay, so reverse the linked list, reverse the array, reverse a file. Wherever reverse concept will come, blindly you can go for recursion. Okay, so even if you want to print in forward direction also, you can use recursion. Only change is nothing but what? That two statements, if you interchange, automatically the problem is going to be resolved. Some people are going to feel, sir, if they have given linked list, they asked me to reverse the linked list. It is very difficult for me to reverse. Nothing will happen, sir. If you trace from the reverse, so inside the stack, it is going to store and it will print. Don't worry, in the linked list, I will demonstrate that. Any questions? Can I move further?
Yes, sir.
So whatever inputs are required for recursion, I have given. So that's all. Theory part is that's all. Now blindly we can jump to the applications and we will develop. Around some 20 to 25 applications we will develop. Can I start the first application with a simple scenario?
Yes, sir.
Yeah. So first application. What is the first application is, sir, I have a string is there. Can you please fetch the characters? Can you please fetch the characters from string? From string. Sir, in which direction? From string in reverse. In reverse direction, I want. Okay, I want to fetch the characters from the string in reverse direction. This is nothing but my first requirement. Okay, we have to fetch the characters from the given string in reverse direction. Let us see how you can develop code for this. Sir, I'm taking one method. So maybe the method is taking one string, sir. What is the string? Assume the string is nothing but something like A, B, C, D. Tell me, sir, how many characters are there? What is the length of this string?
4.
4. Sir, we need to print in forward direction or reverse direction? In the reverse direction. Sir, if you want to get the data from reverse direction, any one index you can take, either beginning or ending. I will take ending index. How to find out ending index? What is the length of the string?
4 minus 1.
4 minus 1. Just for your understanding, I am taking 4 minus 1. Again, don't ask why 4 minus 1. It is length minus 1. Clear? Any queries? Now, at the time of method declaration, tell me how many parameters we have to take here.
2.
What is the first parameter? String. Yes. What is the
String.
second parameter?
Int n.
Can I give index?
Yes, sir.
Correct?
Yes.
Now, see the
Yes, sir.
diagram, sir. I have given the string like A, B, C, D. Sir, what about the indexes? 0, 1, 2, 3. Okay. So, initially, the value of index is pointing to which location? 3. Correct? Can I print this character? Because they asked in the reverse direction. Sir, can I print this character? How to print? Anyone tell me statement? System dot out dot println. How to print? Can I take s dot char at of index? Correct?
Yes.
So I'm removing this println because for my convenient purpose. Okay. Now, sir, after printing this D, okay, first time it is going to print D. How to get the next character? You have to remove this link and ask index to point to this. How to do that? Can I call
Index
same
minus
method?
1.
Can I call same method now? Sir, what is this input? It is yes. What is the index value? You can reduce that. Now what happened? Index is pointing to 2. Can you please print the character at second location? Sir, C. Now index is pointing here. So what is the character present at first location? B. Now your index is pointing here. What is the character present at location? A. Now your index is pointing to which value? -1. Can I stop the process now?
Yes.
Tell me what is the base condition? If
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 index
index
is equal to
is equal to
Index
-1.
-1.
-1, or can I take less than 0?
Yeah.
Then what we have to do? Simply return. We have to stop. Correct?
Exactly.
Now tell me, if you print this, it will print in reverse direction. Tell me, is it a tail or non-tail?
It's a tail.
Tail. Why? Because after method call, there is no statement. Now see what output we are going to get. DCBA. Sir, correct? Is the expected output came or not? Please
Yes.
confirm.
Yes.
Now, what I am doing is one small modification. So same program. So what is the second program I'm going to take? I want to fetch the characters from string in which direction? Forward direction. Sir, I don't want to disturb. Simply, I want to terminate to which one? Non-tail. Sir, can I take this value after this? Now what will happen? Automatically, ABCD will come. No explanation is needed, I think so. Correct? Sir, any questions? Please respond, guys. Clear?
Clear.
Yes.
Yes, sir.
No doubts? Right. So what is the next example? Third example. I want to calculate sum of n natural numbers. I want to calculate sum of n natural numbers. Listen carefully how I can do. Sir, if the n value is 3, what we need to do, sir? Can I take 3 plus 2 plus 1 plus 0? What is the result? 3 plus 2, 5, 5 plus 1, 6. 6 is the result. Correct, sir?
Yes.
Is the common pattern is available or not? Every time we are doing addition only. So I will take a method like sum of n. So assume integer value I am giving like a 3. What will happen? We have to take sum of n. So which parameter it will take? Integer. My common practice is always n. Tell me how to calculate sum. Return type you have to change. Why? Because it will return some result. That's why system.out.println like this. Now in the method also we have to change a return type. Already it is changed. What is the formula? Return n plus sum of n minus 1. Now see the diagram. Sir, first time what is happening? We are calling, so sum of 3, or let me take 5. Sir, tell me what it is returning, sir. 5 plus what is happening? Sum of what is the next argument?
4.
4. Now this one is going to expand. What is the result? 4 plus
4 plus, so yes, sum of 3.
Next what is happening?
3 plus,
3 plus sum of
yes, 2.
Then 2 plus sum of
1.
1. Then 1 plus sum of
0.
Sir, whenever we are getting 0, can I stop? When n is equal to 0, can I return 0? Because return value is expected, right? Clear? Now see what will happen. Listen, this is very, very important. Sir, when n is equal to 0, which value it will return, sir? Can you please tell me?
0.
0 already plus formula is there. 0 plus 1. What is the result?
1.
1. Who called this entire statement? S of 1, right? For this
Yes.
method, it will return 1. Clear? Ah?
Yes, sir.
Now 1 plus 2. What is the result? 3. Who called this entire sequence? S of 2. For that,
Sum
it
of
will
2.
return 3. 3 plus 3. Who called this? S of 3. For them, it will return 6. 6 plus 4. Who called this? S of 4. Return 10. 10 plus 5. 15. Who called S of 5? Main method, right? So for main method, it will return 15. Correct, friends? Sir, clear?
Yes, sir.
Now here I am taking 5. Let me check whether 15 is coming or not. Perfectly coming. Any questions?
Sir, actually, these things are happening in a stack, huh? Everything.
Yes, yes, yes.
Okay. Actually, I just came within back.
Okay, just to go through the recording one more time, because at very beginning, almost 45 minutes, we discussed about stack only. Okay.
Okay, okay.
Clear, guys? Everyone, please respond. Any questions?
No, sir. It's very clear.
No, sir.
Right, guys.
Sir, hello.
Hmm.
Sir, this is non-tail example, right?
Hmm.
Okay.
That's all. No, it is tail recursion only. Non-tail recursion. So as of now, we stopped.
Okay.
Non-tail recursion, a separate chapter is there. I told in the syllabus there is one chapter with name backtracking. Backtracking means non-tail recursion. This n queens problem, Sudoku problem, these things are backtracking techniques. Okay. And even if you are giving any string, generating permutations, combinations. Okay. So even that towers of Hanai problem, subsets problem, everything is backtracking. Soon we will get, but as of now, I stopped non-tail recursion programs. So we will focus only on tail recursion up to certain level. Okay. Right. Sir, similar to this, there is one more program, sir. Sir, I want to take multiplication of n natural numbers. Multiplication of n natural numbers. Tell me, for multiplication, can I take mul of n? What modifications we have to do? Tell me, is there any other modifications we need to do?
Instead of plus, keep.
N into
Instead of
into.
a plus, we have to take n into. But the biggest problem is, this line is the biggest problem, sir. Sir, when it is
N is
returning
equal.
0, 0 into 1 will become 0. Here also 0. Here also 0. Everything will become 0. Correct?
Yes, sir.
Yes, sir.
So what we have to do? When n is equal to
N
0,
is
can I return 1? Because 1, if you multiply with any number, it will become that number only. It won't give any change, right? Correct, guys? What is 1 into 1? 1. 100 into 1? 1. 75 into 1? 75. There is no change, right? Understood, everyone? So it will return 1 here. So 1 into 1, 1. 1 into 2, sir, 2. Sir, 2 into 3, 6. Sir, 6 into 4. What is the result, sir? 24. Sir, 24 into 5. Can I say 120? Sir, can you please tell me, is it a factorial program or not?
Yes.
That's all. If anyone is asking factorial of the given number using recursion, this is the program. Clear? Any questions?
Sir, actually, we
Hmm.
can do normally also. What is the use of a recursion function?
No. As of now, don't think about that. Just we entered into the recursion. First, we need to solve some programs. Finally, I will tell where you have to use recursion. Okay.
Okay.
Sir, clear up to this?
Yes, sir.
Sir, any questions? Please confirm. Can I go for one small complex program? With that, I will stop.
Yes.
Right. Sir, how you have to think? This program will explain. I want to do multiplication. Okay, I want to do multiplication of two numbers using recursion. Sir, two numbers multiplication simply you can do by using into. So, okay, no problem. But I want to use recursion. Sir, multiplication means what? If I take 2 into 3, what is the meaning of that? 2 you have to add 3 times. Am I right?
Exactly.
Sir, 2 into 100 means what? You have to add 2 how many times?
50
100
times.
times. Oi, 100 times.
Sorry, 100.
Correct? Sir, here also, can I say is it addition of numbers only, right? So what I will do is MUL function I am taking. How many parameters we have to pass? 2 parameters, 4, 2. What is the expected output? 8. Now I am changing this method name as MUL. How many parameters it is going to receive? X and then Y. Okay. Now I am writing the formula, sir. Now tell me what is the formula? Can I return? Okay. Can I return X plus multiplication of X comma Y minus 1 I am taking. Sir, multiplication of 4 comma 2. First time 4 plus multiplication of 4 comma 1. Next time 4 plus multiplication of 4 comma 0. Sir, whenever 0 is coming, I will return 0. 0 plus 4, 4. Sir, 4 plus 4, 8. Is it correct, sir? Is my explanation is clear? When we have to stop? If y is equal to 0, we can return 0. Sir, or even if x is also 0, we can return 0. Because in the multiplication, if any one number is equal to 0, result is 0. Are you clear with the logic, friends? Please confirm. Array, tell me, are clear?
Yes, sir, clear.
Yes, sir.
Now I am running this program. I got 8. Now observe carefully. I am taking 2 comma 4, sir. What is the expected output? Tell me, 2 into 4.
8.
8
8.
only. What is a tree diagram for this? First 2 comma 4. Then, sir, 2 plus m of 2 comma 3. Then, sir, 2 plus m of 2 comma 2. Then 2 plus m of 2 comma 1. Then again 2 plus m of 2 comma 0. Now my question is, both are correct. Tell me which diagram is very big, complex? First one or second one?
Second.
In
Second.
multiplication, there is one rule. A into B is equal to B into A. Correct?
Yes,
Yes,
sir.
sir.
If you swap these two numbers, it will become this one. So that within 3 calls we can wind up. But here 1, 2, 3, 4, 5 calls. Can we reduce this?
Yes,
So
sir.
I don't want this. I want to go for this one. How to do that? Very simple, sir. Here after if condition, I am taking one more thing. What is that? If x value is less when compared with y, can you please call multiplication by exchanging y comma x? Now see in the red color I am marking. Sir, whenever you are calling m of 2 comma 4, since x is less, then what will happen? It will redirect to m of 4 comma 2. Then again it will be same. Understood, friends?
Yes, sir.
Yeah.
Anyway, in both the cases, the answer is the same, but the only thing is we are trying to reduce the method calls. Remember, some person asked just a few minutes back, when we have loops and all, why you are going for recursion? So recursion is somewhat tricky and a costly operation. If there is no chance, then only go for recursion. So in the recursion, you have to try always to minimize the number of codes, the number of instructions. That is very, very important. Okay.
Yes.
So as of now, how many applications I covered? Sir, 5 applications we have seen. Like what are the applications I covered? What is the first one? How to fetch the characters, and the second application, I mean, in the reverse direction and in the forward direction. Then we have seen sum of n natural numbers. Then we discussed multiplication of natural numbers. Sir, even the multiplication of two numbers by using a recursion also I covered. So these are nothing but 5 applications which we discussed till now. Any questions up to this?
No,
No,
sir.
sir.
Right. With this, I'm going to end up today's session. And tomorrow also, as usual, we have a session at 9 o'clock. Tomorrow I will wind up this recursion. So tomorrow around some 20 applications we are going to discuss. Okay. So please refer this video before coming to the next class. From next week onwards, we will have our regular classes. What is the timings of our regular classes? Please tell me.
7 p.m. to 10.
7 to 10.
7. Yes, very good. 7 p.m. to 10 p.m. Okay. So the next class is from 7 p.m. to 10 p.m. Okay. Any other questions that you need to ask?
What is the course fee, sir, now for this?
3,000, sir. 3,000. 5 weekends.
Sir, like, can we complete in 10 days? Whole DSA.
Yeah, yeah. 5 weekends in the sense the classes will be only on Saturday and Sunday. So maybe if time is not sufficient, maybe 1 week plus nothing will happen. Okay. Excluding this week. Don't stick on to timings. Maybe plus or minus 1. That's all.
And
At
sir,
very
moreover, like, are
beginning,
you going to
tell me.
cover some like hacker rank or lead squad problems?
No, sir. No, sir. No, sir. Because this is only beginner level program, sir. So I'm going to give the guidance how to start a DSA. Okay. So once if it is started, then you can do that by yourself. Because if I'm explaining the program how to think, then nothing will come for the student. So based on the knowledge, you have to try. If it is not coming, keep on try for 4 to 5 times. Then definitely you will get. See, if I explain linked list program, with this knowledge, you can able to solve 100 plus programs. But the only thing is, knowledge is important, right? So practicing and all you can do by yourself. If I explain those things also, then you won't learn anything. That is very, very important. The students are lagging in that. They will ask, sir, can you please tell me at least 10 lead code problems? If I explain, I will get, you won't get, right?
Yeah.
So if you have a stack programs, you need to understand what is a stack. If you are clear with the stack, start implementing. Try to understand the problem statement. So don't stick on to time. If it is taking 1 hour or 2 hours or 1 day also, please spend some time with a clear mind. Try to solve. Okay.
So like you will be providing with some assignments to us like weekly.
Yeah, definitely. Definitely. Any questions?
Sir, are you covering bitwise operations?
Sir, I forgot to add. Sorry. Definitely, sir. That one I am going to cover. Okay. Like bit manipulations, because this is also very, very important. Bit manipulations. Maybe some 5 to 6 applications I will develop, but I will give the revision of bitwise operators. Okay. Any other?
Yeah, if any day you are going to start from 5 o'clock, then please let us know in the morning.
Sir?
Anytime if you are going to start at 5 o'clock, please let us know before at the morning itself.
Yeah, sure. Sir, the timings of the session is very strict to 7 p.m. to 10 p.m. Sometimes, because maybe next weekend or after that, I'm going to take linked list. It is a big concept, sir. Okay, you need to get some time for practice also. That's why on Saturday, I'm going to start 1 hour or 2 hours before. So that 1 day prior intimation I will give. Definitely 1 day prior intimation I will give. So same link only will be there, but you have to join at 5 o'clock or 6 o'clock like that. Continuous at a stretch, one big program I'm going to demonstrate. Only maybe for linked list and for AVL trees and for graph. Only for these three concepts, you may get 3 sessions. You need to log in at 5 o'clock. The remaining all the sessions as usual from 7. Clear, guys?
Yes, sir.
Yes, sir.
So tomorrow, as usual, we will have a session at 9 o'clock only. So tomorrow we are going to finish this recursion. Okay. And from next week onwards, we will have our regular classes. Okay. Once if you are clear with the recursion, then only further concepts, it is very easy to understand. Okay.
Thank you, sir.
Yeah. So from next week onwards, our classes will be 3 hours. Please available on that time. Meanwhile, breaks will be there. Maybe 1 or 2 breaks I will provide.
Okay, sir.
Yeah. Right, guys. Thank you. We will meet for the continuation tomorrow.
Thank you, sir.
Thank you.
Thank you, sir.
Sir, these are all comes from C programming, right?
No. Data structures is independent of programming languages. You can
Okay.
solve this using C or C++ or Java, Python, JavaScript, anything.
Okay, but names will be different, right? There.
Yeah.
Okay.
No, concept is the same. Implementation is going to change.
So, but we have already functions, right? When we are going to really use these, these concepts, we are actually for everything there is a predefined functions, right? For every programming language.
No. Some things we have to develop by own. We don't have predefined functions for everything. How those predefined functions are developed? By using these things only, right?
Yes, sir. That's what I understand. For example, in Python, list sort method is there. It is sorting. Here, sorting algorithms are there, like bubble sort, greedy. How can we?
If interview person is asking in the Python, you are going to take L dot sort. If interview person is asking how internally it is happening in the background, so the people who knows data structures well, they can explain very clearly. Okay. Yeah, right, guys. Thank you. See you in the tomorrow session.
Sure, sir.
Thank you.
Thank you.